Okay, so we're going to go ahead and actually take a look at calculating speed today, making sure you understand how to do your speed calculations properly. Yesterday, when you completed your lab, you got to explore calculating speed. You got a chance to measure distances and then find the time it took for objects to travel. So now we're going to take that a step further and we're going to look at some of the types of problems that you might see on your test, on STAR test, or even in the future as we start looking further into Newton's laws of motion. To review, remember that in order for us to calculate speed, we have to look at the distance that an object travels and then divide it by the time that it took. So if you look at the first example here, there's a roller coaster car that rolled 20 meters on the track in 15 seconds. What was the speed it was traveling? Of course, you know that the formula is speed equals distance over time, which means that's 20 divided by 15. When we do 20 divided by 15 and we get that calculation, we get a speed of 1.3 meters per second. If we look at this next example, it says that an eagle had taken 30 seconds to fly 170 meters. What was the eagle's speed? Notice that this problem says round your answer to the nearest hundredth. Pay attention to your questions and make sure that if they tell you what to round to, that you actually do round to that number. That could determine whether or not an answer is correct. So in this case, we know that speed is distance divided by time. And we know that the distance was 170 meters and the time was 30 seconds. And so if we divide 170 meters by 30 seconds, we get 5.67 meters per second when it is rounded. Once again, a school bus traveled 86 meters through the neighborhood and took 450 seconds to do so. What was the average speed that the bus traveled? So what you can do right now is go ahead and try this one yourself. If you are following along with the guided slideshow. If not, you need to go ahead and open that now if you haven't done so already. So that way you can plug in the numbers here, which would be 86 meters divided by 450 seconds. If we drag this box out of the way, you will see that your answer is 0.19 meters per second. Now, let's say you're looking for the time instead of the speed, which means your speed is there, but your time is not. In this case, there's a couple of different things you can do. The formula for speed, of course, is distance divided by time. But if you adjust the formula in the same way that you solve for x in a math equation, you can find the time instead. And so if you notice, based on the triangle too, time is actually distance divided by speed. Here I give you an explanation of how you can go ahead and get this by getting your variable, which is the question mark, on the side by itself, so that way you can solve for time. And so what you end up with, of course, once you do that, is time equals distance divided by speed. That is how you would go ahead and solve for time. And then, of course, if you do your distance divided by your speed, you can get your time here. Now, what if you're looking for distance instead of speed? Again, you can change the formula around by doing your math conversions in the same way that you do in any other math equations. If speed is there and time is there, then in order to find distance, you're actually multiplying speed and time to each other. Once again, I give you an explanation here of how you would go about isolating the variable, which again is the question mark, to prove how you get that formula change. So distance is actually speed times time. So what we'll do here is we will try a few out. A plane was traveling at a speed of 3.8 meters per second and did so in 220 seconds. How far had the plane traveled during that time? If speed is distance divided by time, and when we change the formula, we know that distance is speed times time, then we would take our speed of 3.8 and multiply it by our time, which is 220 seconds, and we would get our distance. So I'll give you a second to go ahead and do that. And your answer should be 836 meters. Notice that I put a little note in here. Did you remember to include your unit of measure? Next, the teacher had walked a distance of 8 meters and her speed was 0.76 meters per second. How much time did it take for her to walk that distance? If our speed formula is distance divided by time, and we convert that formula, time equals distance divided by speed, then that means we would divide 8 divided by 0.76 to get our time. Time is measured in seconds, so remember that unit of measure should end in seconds. 10.5 seconds. One last thing to remember before we wrap up this guided practice. What if your time or distance are not in the correct units? So if your time is in minutes, you need to convert it to seconds. Remember, there's 60 seconds in a minute, so you just multiply the minutes by 60. And of course, if your distance is in either millimeters, centimeters, or kilometers, you have to make sure you do your correct metric conversions to change it to meters. This is one of the reasons why metric conversions are important to remember. For example, if I have 0.08 kilometers, that equals to 80 meters because I would move the decimal over 3 times. In this case, 1,200 centimeters is equal to 1.2 meters because I would move the decimal over 2 places to the left in order to go from centimeters to meters. Be sure that you are comfortable with your metric conversions because you may need them every once in a while, especially if your measurements are in centimeters or kilometers. That way you can convert them to meters. You should now be ready for your independent practice, and you can go ahead and open that up now.